Here are some keywords like top-down design, pseudocode. Pseudocode is something that we have used on HL level Thursdays. Do you remember what is pseudocode? Pseudocode.
Code, the code uses actual language instead of how do you call it? It uses like actual words, so it would be easier to understand.
Yes, kind of. This is something that we write for other human beings of whatever background on computer language. For instance, there are programmers. One programmer can Python, another programmer can C, the third programmer can PHP, and we have to present one algorithm for all of them. Then we can write it down in pseudocode, and they can translate it from pseudocode into their own language that they can. So there are some rules that also you have to follow if you write your own pseudocode. So here is an example how to write arrays. They propose that all the variable names must be in uppercase, which is in contradiction to my proposal to write all the variables in lower camel case, because in uppercase we only write constants. What is a constant? Constant is like a variable, but its value is not changeable, or we just don't change it ever. So I have no idea why they propose to write all the variable names in uppercase. For comments, this is okay to use two slashes. And for arrays, such a notation with brackets. Here is an example of strings. Again, the variable name is in uppercase. And there is also a conditional part. Here is only one equal sign. I do not encourage you to write pseudocode like this, because normally in programming languages this sign is assignment sign. We assign the thing on the right side to the variable on the left side. What operator should we use instead of this here for comparison? What's okay? There is no such operator, okay. Can you answer my question? You have done it on Thursdays. What operator should you use for comparisons? Yes, writing equal is also acceptable. That way another human being also understands what is meant. But if we only write this sign here, this can be understood as we assign the to my word, and the condition is all this, so this is the value of my word. The value of my word is the converts into one or true. That means if true, then output, which is wrong. So here another way is to put two equal signs. Then if we want to output something, so instead of console.info in JavaScript or system out print for Java, we can just write output. And everybody understands that here we want to output the thing that is after the word output. Sometimes there are some functions proposed that we can use, like char at or substring, and we can use them in our pseudocode as well. So here is an example of collections. We have not covered it yet. A collection is like an array, but it's quite limited. It's rather like a linked list, so every item only has linked to a next element, and we actually do not know how many elements there are in that collection. We have to walk it through first. And how do we write loops? Just with the keyword loop. We can add here another keyword like while or from to or until. Here are some methods of collection, like add item, get next, reset next, has next is empty. And for stack, push pop is empty. And for queues, that we will cover tomorrow, and queue, the queue and is empty. And here it's just a complete example how to use pseudocode. It's pretty similar to JavaScript. Okay, this was this file, and there is another file, rules more. Here they tell the things, how every keyword should be written for IB. But actually there is also another rule that if you write it a different way that is also understandable and meaningful, then it's acceptable as well. It is pretty... Pardon?
We have to write the real code.
Not real code, but pseudocode. But it is always good to know how to write in a real language, like in JavaScript, because otherwise you cannot test it anyway. During the exam you cannot test it anyway because you have no help means there. How to write this sign with computer, I have no idea, but on paper you can do it. In computer you can just write exclamation mark and equal sign. Then for charts, for activity diagram, you can mark activities like this one. Actually, there should be rounded corners, or this one. This one I do not prefer because that way in UML we represent components. So here is conditional. We create a software that contains modules so that we can add additional functionality without altering the current system. So we just add a new module and connect it. Can you bring an example of software with modular design?
Oh, software.
Or hardware.
Oh, first of all, Raspberry Pi. Machines that are used in the biology and chemistry, you collect modules and they all do things.
You can connect them to the plate.
And here is the upcoming Google project. I'm trying to name it, but modular phones.
And now for software.
Eclipse?
Yes, Eclipse. You can add plugins without altering the main code.
OBS.
What's OBS?
Open Progress Software. Open Progress Software.
Ah.
Or live streaming and recording video, and you can install many different plugins.
What
open
do
source, you can pretty much do anything.
What do those plugins do, for instance?
Well, you can have it like not in the sidebar, but on the screen. So that's what I pretty much want things you can add to plugin.
So, and I also encourage that you program every software in modular design, because otherwise if you want to add a new functionality, you have to make a lot of changes, and testing that other functionalities remain functional is also complicated otherwise. Next one is an example of an algorithm. How does a fridge work? You know what is a fridge? Have you seen a fridge?
Of
Yes.
course, I think all of us have one at home. At least one.
Have you
One on my own.
have you ever
One in the sauna and the other one
One in the sauna.
because that's where all the output things are.
do you have a modular fridge?
Not really, because the fridge itself doesn't have a freezer. Freezer is a separate one, but it's as big as the fridge itself. So it's not modular.
So
Gigantic
have you ever used the fridge?
fridge. Yes, of course.
So
Every day.
So here is an example of how a fridge works. First, the software in that hardware of a fridge asks for a temperature. If it's too high, then it starts the engine for cooling down. And if it's too low, then it stops the engine. And then it waits for a minute, and then it asks again for a temperature. And does the same things. On the slide 87, there is the same algorithm in pseudocode. So this is a loop. While the fridge is running, do those actions that are inside the block. Sometimes people write pseudocode without block characters. I encourage to use them, because that way we always know what is inside the block.
It says wait 1 minute, but isn't it bad if the temperature change happens too quickly?
What?
Isn't it bad? It says wait 1 minute, but isn't it bad if the temperature changes in the fridge too quickly?
Too quickly?
Yeah.
No, every 1 minute it checks for the temperature. If the temperature,
It shouldn't be wait one, it should be cool down 1 minute.
there is start engine. So if the temperature is too high, then it starts the engine. The engine works and works and works until another minute is gone. Then it checks the temperature again.
Makes a lot more sense now.
Mm-hmm. So, and then it checks again. So now there is the next exercise about activity and state diagrams. Activities are part of use cases. So you draw all the possible activity state diagrams for every use case of the project. And first I show for you how to draw an activity diagram. Draw I/O diagrams. Let's do it for the fridge. Actually, the use case could be what? What could be the use case? What is the actor?
Fridge.
Yes, fridge is the actor. And what is the use case?
Open fridge.
Or rather running. So how does that running or keeping cool use case work? Start, then it checks for the temperature. If the temperature is bigger than the maximum allowed, let's say that the max temp is written in as a constant. So if it is bigger than maximum temperature, then we add activity. For activity diagrams, we only use those yellow symbols. So let's put here activity. This is stop engine. Now this is for no part. Or actually it is not here at all. Because the temperature is too high, then it should stop. Start engine, yes, start engine. This is the yes text here. So. And if it is not, it should make another check. Not necessarily, because otherwise it would stop all the time if the temperature is not too high. If the temperature is normal, it also stops. But if the temperature is less than minimal allowed, this is the if-else block here. If temperature is less than min temp. Now it should stop the engine. And the end symbol is this one. No, it does not go to the end. There is another action. What is the last action?
Wait 1 minute.
Yes. Wait. This goes here, and this goes here as well. And then it goes back. Actually, there is no end at all here. It's an endless process. And yes, here it goes. Not there. I have no mouse here. So it goes here. Back here. Oh, that's wrong. Here should be arrow. And if it is no, it also waits a minute. So this could be an activity diagram for the fridge working algorithm or fridge running use case. Usually we should include an end element as well, but here it is designed to never end, only if we switch it off. now you know how to draw an activity diagram, and kindly do activity diagrams for your use cases. Yes, yesterday you did write the steps. The steps are the ones that you present an activity diagram.